So I realised I didn't introduce myself either at the start of today's session. My name's Alice Morgan. I'm from the University of Reading and part of the EFL team. And Julia Cooke is from the Open University, and she will be talking about a survey that she's running on the longer term impacts of COVID-19 on ecology teaching. Okay, thank you, Julia.
Thank you. I'm just going to put it in a better view. Hopefully you can hear me. Maybe give me a thumbs up if you can hear me with this microphone. Yep, okay, brilliant. Thank you very much, Alice. I'm a late addition to the programme because we had someone withdraw, and I said, brilliant, I'll take the spot because we're running this survey and it would be lovely to reach everybody that we are able to connect with today. So together with my colleagues Becky Thomas and Barbara Tigger and a range of other people that you can see listed here, we're interested in how the longer term impacts of the COVID-19 pandemics are affecting ecology teaching at the moment, and we're aiming quite ambitiously for a global perspective. So we're all very aware, and we've seen that very much during this conference, that during the COVID-19 restrictions, how we taught ecology changed enormously. We've seen some fantastic case studies in this program and survey results and interesting understandings of what changed during the pandemic and how people, ecology teachers, responded so magnificently to the restrictions that they had. I think for ecology, field teaching is a particular challenge. I know other fields also teach in the field, but it's sort of different to maths and stats and all those sorts of things for field teachers. But I think we changed a lot of things. We changed how we delivered core teaching, how we did assessments and all those sorts of things. So we want to use this as an opportunity to explore how that change happens and why change fails as well. We made massive changes because we had to. Now what are we doing? Are we reverting back? Are people unable to continue the good changes they made? Why didn't things work? Why things aren't being maintained? And I guess it's an attempt to make use of this disruption. You know, we all wish the pandemic hadn't happened, but given it has, what can we do with this? How can we maintain it? And let's not let good crisis go to waste. What we want to do is collate all the information that people have and the different practices, things, the new practices people developed, the good, the bad, everything, and put that together and then share it. So I think what we've heard a couple of times in this showcase is people saying I feel like what I'm saying is falling on deaf ears, or we've tried to argue for this change to be embedded in our curriculum now, but you know, they just will say, let's go back to the old way. So maybe if we can put everybody's experience together and show how broadly some of these changes have been applied and implemented or not, this will be a useful thing that you can then take back to your school. So one way we were thinking of looking at this is using this framework. So it sort of says there's 4 different things that can happen. So this end are things that we did to respond immediately to the crisis, and we don't need to ever do them ever again. They were right for what we did at the time, but no more. You know, nobody wants to use that system again, so we will end those. We can amplify things. So these are things that we were able to try in response to the pandemic, and they worked really well, or they show promise for the future, and we can take those forward. I think an example is where people came up with online alternatives for fieldwork, and they want to return to the fieldwork, but they now have this online option for students who get sick or can't access things, so you can increase the accessibility, but you also return to things. So maybe something like that is an example of something that's amplified. We can let things go. I've been an external examiner for the first time this year, and I've seen people say we used the pandemic to end some things that were just crappy that held on, and we said no, we're having this big upheaval, so let's actually make some changes, and to stop doing some things that were already unfit for purpose, and things that are going to be restarted. So I guess, you know, classic in-person fieldwork is an example of that, where they had to stop during the pandemic and now they're restarted. So these sort of 4 things, we're expecting that we will find examples of all of those, and hopefully we can collate them to help everybody teaching ecology. What we're proposing to do is a Delphi survey. So this allows us to collect both qualitative and quantitative data. So in the first round, we're going to sort of try and reach as many ecology teachers as we can, ask people what restrictions they faced, ask people what they changed during teaching, through necessity and through opportunity. We're interested in the challenges and the triumphs. You know, some people just came up with these fantastic things that were amazing, and we'd love to hear about those. We're also aware that there are ongoing challenges, you know, people who have come up with these things and they work, but the bureaucratic system of the university won't let that continue, and sort of all sorts of challenges, or that there's not the software availability, or there's not the training, all those sorts of things. We want to know what are the ongoing challenges for ecologists. Then we will take out all your personal information and use that to say we reached 17 universities and half our respondents were had yellow hair or whatever. We'll just use that sort of to summary statistics, and we will take all of the information you gave us about teaching and recirculate that to everybody to see how widespread those changes were. So if you fill out the survey and you sort of make some comments, and then when the second part of the survey comes, I think, oh, I did that too, but I didn't tell you in the first part of the survey. This second round will let us quantitatively assess how many people ditched lectures forever, or how many people did this, that, or the other. So there'll be two parts to the survey. One more qualitative, collecting that initial data, and the second will allow us to get some quantitative data. Which brings me to the last slide, which is please fill out our survey. Hopefully by doing this, you'll help us to help you. Alice and Catherine, which is brilliant, have both shared this in the chat. So you can fill it out now. It will take a little while. It's probably 20 minutes. So maybe just open that file in your browser, save the link, email it to yourself to do tomorrow. I don't mind. And then please send it to your colleagues. Two of our collaborators are based in the States, so we're hoping to reach some people in North America. And then we don't just want England and North America. It'd be really nice to have people all over the world completing this, because, you know, it's pandemic affected all of us. I don't think there was anybody who escaped. So we'd really appreciate you responding to that. And please get in touch. Oh, it says page not found. Oh no. Right. I checked it this morning and it worked. I think I won't hold things up anymore. We can go to the next speaker, but I will find a link that works. And oh, poo, I checked it.
Yeah, it's not there.
All right, thank you very much, folks. And well, I guess knowing the link doesn't work means you clicked on it madly, and I very much appreciate that. So I will find another link and share that. Thank you.
Thank you, Julia. Brilliant. You've got a good audience there to complete the survey. Yes, please, Jenny. Okay. Thank you for also keeping to time. We've got spare time today, which is very nice. Excellent. So we'll now move across to our next speaker in this session, also from the Open University, and also covering a speaker who couldn't attend. So Jenny's kindly stepped in to give us the talk today. And Jenny will be talking about teaching environmental science students in the UK using mobile devices, capturing current data from Malawian macadamia nut farms.
Yeah. Okay, can everyone hear me all right? That's a bit weird. Does that stop? No.
I don't know.
That's strange. I wasn't doing that for Julia, was it? Have we pushed something on there? Oh no, I'm gonna start.
Sorry, could you say something?
Oh,
Sorry.
hello.
No?
No, it's still good.
No, why would it do that? Have a look.
Shall I try again? Is that better?
Can you get to the real tone? There we go.
Okay. Take control on here.
That's probably a reason.
Oh. No.
Worth a try.
Okay. Yeah, that's good. All my notes on my papers as well. Okay, now is that better? Hear me? You hear me okay online? Oh, I haven't got the chat. No, still echoing online apparently.
Okay, just check if you hear phone on the devices.
How about now?
Still.
And just go with this little change.
Try now. I don't know.
Okay.
I think someone might put the mic on.
Yeah.
Oh, someone online?
Yeah.
Oh, okay.
That's right.
Okay, so
I've just changed the configuration here, so I'll just finish the changes. Can folks hear it now?
That sounds good now. Yeah.
Brilliant.
Is that meant to be on or off?
That should be on. Not as in.
It should be like that. Okay, right. Shall I try again? How about that? Can you hear me okay now?
Yep.
Yes, that's okay. Okay, good. Fantastic. Right, lovely to see you all. I'm the stand-in today. This should be Joseph Araya here, but he's in Prague for a agroforestry conference, as is Emmanuel Zouza, who also might have been talking to you. So bear with me, please. So I'm Jennie Bellamy. I'm a staff tutor here at the Open University in the School of Environment, Earth and Ecosystem Sciences. So we're looking here at environmental science students in the UK using mobile device captured current data by Malawian macadamia nut farmers, which is a bit of a mouthful. This is a collaboration between Environment, Earth and Ecosystem Sciences at the OU and the Nano Macadamia Trust, as you can see, and also the Highland Macadamia Cooperative Union. Let me move on. Okay, so a little bit of background. You're probably aware of where Malawi is in southern Africa. You can see there on the map. The area that we're dealing with, Nano, is in the southern area, and the map on the right there shows you the areas suitable for farming macadamia. Macadamia was introduced to Malawi in the 1950s from Australia, where it's a native species. And it was introduced as a cash crop. As I said, it's linked to agroforestry. It can be grown with cash crops like coffee or maize, food crops as well. There are concerns that climate change is going to reduce the area where macadamia can be grown. Currently, it's a large area of the country, as you can see. Okay, so what we're doing is we're linking up the macadamia farmers with our students here in the UK at the OU. And, oh, sorry, there's a bit more information there about macadamia. So it's an important crop for the smallholders. It benefits food security in Malawi, but there are challenges, of course, so low yields. And the different clones, the cultivars of the trees, are linked to different climatic zones. The data can be very interesting to use, which is why it's important for our students. but more about that in a moment. And what happens is that the farmers on the ground collect data based on the yield, the number of people in their household, things like that. But another challenge is that they have to wait for about 3 or 4 years before the first crop yields. And that can be a significant problem for them. And as it says there at the bottom, the live data is used for teaching university students here at the OU. So a bit of background to the project. The collaboration came about by chance after a media developer here at the OU gave a talk to the School of 3Es about his volunteer work in Malawi. And that's how the project came about, really. But the farmers are motivated to participate because they can improve their productivity. They find out information about how they can improve yield and so on. The students use raw data. These are students on SDT 306 environment responding to change. And they're also useful skills for the researchers and the farmers using these techniques on the ground. Okay. So the technical details. So the Trust collects the data from the farmers digitally. They input the data into mobile phones. The data is usually around the trees, the yield, how many people in their household, information about the environment that they're in, so what the soil is like, that kind of thing, and also which clone they're growing, which is important. And you can see one of the farmers there in the picture. So what do the students do with the data? The students are from all over the university, really. SDT 306 Environment Responding to Change is a very broad-ranging module that attracts students not just from geography, environmental science, environmental studies and natural sciences, but also business, design, law, technology. So it has to be very accessible in lots of different ways. They also have, in lots of different circumstances, so they could have caring responsibilities, they could have disabilities. And they use the data to carry out statistical significance tests. So they might be linking something. Oh, the echo's back, apparently. I wonder if that's because there's a lawnmower outside. They might be linking altitude and yield, or soil type and yield, the number of people in the family and the small holding versus yield. So the students set up a hypothesis, so something like there's a significant difference in yield between small holdings on sandy soil compared to clay, or there's a significant association between the yield of macadamia and altitude, that sort of thing. So the students need to come up with a research question, hypothesis, and then write their report. They also do some qualitative work as well for that same assignment, also based on the data that we have coming in from Malawi. Okay, so what do we hope the students learn from this? Those of you at the OU will recognise OU style learning outcomes here. Well, we hope they'll learn through doing, as always. They need to initiate and design an investigation. They need to choose the right data for the task and interpret the findings. They need to understand the concepts, including causality, appreciate uncertainty, consider different perspectives. And there's also links to employability and transferable skills. And we also hope they frame their findings in the research literature and make links to climate change. Okay, what do they say about what they're doing? I won't read these out, but there's usually a realization that real data is very messy. It has gaps and inconsistencies, and that can be quite an eye-opener for them, because often in their lower level studies the data is sort of cleaned up and and made a bit more easy to use. So when they get to this level, it's a bit of a revelation. So you can see from their comments there, if you read them through, that they're expecting us to make things easier for them. Sometimes they need a bit of pragmatism. On the slide before was one of the charts that the students had one of the students had put together, and there was one outlier. Some of them will notice that, some of them won't. So yes, we need them to see the inconsistencies and consider the limitations, of course. Okay, for the future, we're hoping to have more of a link back to the smallholders and the farmers from what our students find. That isn't really happening at the moment. We're also hoping to have a greater link with the smallholders themselves. I think my last slide is just how to find some more information about the Nano Macadamia Trust, and a couple of Emmanuel's articles there as well. I think that's everything that I intended to say, just about. How was that for time?
Yeah, lovely. Thank you.
Thank you.
Great.
Questions later, isn't it?
Yeah, we'll do questions towards the end of the session. That's great. Thank you very much. And we now move to the final talk in this session, which is a talk from Jon Hale from the Beaulieu Convent School. Jon will be presenting online. So, Jon, are you there?
I hope so. Can you hear me okay?
Hi, we can't hear you in the room. Just one second, Jon. I think we need to turn the TV back on again. I think it was the online thing that was the problem. Okay, try again, Jon.
Hello.
Brilliant. Excellent. Thank you very much.
I get a nice echo now. So. So yeah, I'm Jon. I'm head of biology at Beaulieu Convent School in Jersey. And we've kind of gone on a little bit of a journey over the last probably year and a half to kind of make ecology a lot better in the grand scheme of things, and make it a bit more meaningful for students. Just a little bit of background: the Ecology GCSE, and we're thinking about the students that are doing the combined science rather than separate sciences, but there's not much difference between them and the students that choose to do like a biology, chemistry, and a physics GCSE. It's one of 7 big themes alongside like cells, the bioenergetics, diseases, genetics, evolution. It's got some marvelous things in there, like interdependence, the communities, the adaptations of plants and animals, biodiversity, the carbon cycles in there, the water cycles. It's really loaded with knowledge. But there is a problem, and that is that it goes at the very end of our curriculum. This kind of big picture where we build up from the small to the very large seems to be ingrained in terms of how we teach biology in secondary school. And with the time that gets eroded away with every kind of, let's say, an assembly here or a school trip there becomes less and less time to make the ecology the topics that it needs to be, to give it the time and the focus that it really needs. And that's a big challenge for us. So a little bit on our school, and we're incredibly fortunate in that we've got 3 specialist biology teachers for our school. We've got backgrounds in zoology and genetics, and myself as a pharmacologist. We're not ecologists, but we have an interest in it. On the other side, it's an incredibly urban environment. You can see that the playing fields are astroturf, and there's very limited in terms of what we can use. There's an awful lot of tarmac and a handful of trees. When it comes to what we can actually use, we've got the astroturf. This currently red section is being turned into a PE building. We've got a handful of hedges, a pond, which we'll show you a picture of later, a grassy verge, and yeah, a little tiny bit of a wood, which is remarkably challenging to get to with a group of 20 girls that are scared of brambles. But we do what we can, and we try and build a narrative using that grassy verge mostly on that edge of the astroturf. It's only 9 meters wide, to give you a little bit of a sense of scale, but it's all about them. So the first thing we do is we go out and we literally see what we can see. We get the students to only have to spend 10-15 minutes and find as many different types of leaf as they can, and they do pretty well. It's kind of developing this idea of observation skills, but it's a nice way of introducing meaningful maths as well, so we can talk about the range of values when they just put down how many different species they saw. We can start thinking about what is a mean, what is a mode, and what does variation kind of look like as well between different people's leaf samples. And it's a little bit of a discussion starter, but those leaves have a purpose, and that purposefulness comes through a little bit more as we go through the classification, where it's about the students seeing what they have and looking for what makes this the same, what makes it different, what are the similarities. They can see that they're green, leaves are green, they're flat, and the vast majority of the samples they choose. They have an idea of what a leaf should be, but then they start to look deeper and they start to see what the edges of these leaves are, and they start to see and they start to annotate and they start to make observations as scientists. And that for me is the important bit of ecology. It's not just doing things for the sake of it, but making them invested in what they do. So the next little bit is inspired heavily by Dr. Catherine Forsey, who does a lot of work with primary schools. So a lot of these kind of bits are dripped in, like the wrapping a tree with the bubble wrap. Is really great. You leave it for like 3 days and you can see there's a tree in the background and a tree in the foreground, two different types of tree. We start to predict which one will have more invertebrates. The best thing we've managed to find is like a worm about 2 meters up on a tree bark, which is a bit unexpected, but things like woodlice you would expect, spiders that come through, and it starts breaking down those barriers to invertebrates that they have. We do a little bit of the kind of tree bashing or bush bashing, and again they just start looking and they start to see the unseen. Likewise with this pond, and I use that term loosely, it's a box with some water that is overgrown with duckweed and some other non-desirables, but it's got in there some water hog lice and leeches and things like that that they can kind of look at and appreciate. We go around a little bit more, and this is not our school site. This is a little bit of a coniferous wood, and we do a Tolgren funnel, so we try and compare how they see this. Is there going to be more or is there going to be less in terms of the number of different species? And we set up parallel Tolgren funnels, the ones where they look at this and think, hey, wow, this looks really, really nice. And then we compare it to our deciduous woodland on site. We can find little nice things. If you have a little look in the bottom corner, you might see a little pseudoscorpion. There's little things that I hadn't seen personally until last year from doing our little resequence. But they get to see that actually certain types of plants support more life, and they start to make those decisions for themselves. They're still processing and analyzing that information, that data themselves. We do a little bit of a plot of species richness, and we start plotting what ranges of data people have. So they're adding in the depth to their data analysis. But it all comes to this end point of making the required practicals of our spec as meaningful as possible, coming back down to this little strip, this 9-meter verge, actually having purpose. Like, these students are like 12 and 13 years old, and the work on the right is the kite diagrams, or the kite diagrams they produce from the data they collected, and they're able then to start to make those really, really purposeful evaluative and conclusive statements in how they make their predictions. Like, why are certain plants only found close to the astroturf? And they start to think about things like the salts and the sand that are put down on there, and they start to think, hey, we only find mosses at the top of the slope. Why are we only finding it there? And we have this idea of a battleground. And then they're able to bring that into the bigger global pictures when it talks about adaptations in the rest of the course. So that is the whistle-stop tour of our resequencing, making ecology hopefully have a little bit more meaning rather than a squeeze by putting it at the front of the course rather than at the very, very end of year 11. So thank you.
Great, thank you very much, John. And again, also keeping to time, today's speakers are doing brilliantly at that. So we've got some time for questions for the speakers from this morning's session. Brian, shall I pass across to you?
Yes. There's one from Janet. Can you clarify what the farmers gain from participation? And Jenny's already responded to that online.
Yes, is that okay, Janet? Does that explain? Sorry, did you hear me?
Yeah, that's great. Thank you. Thanks. That makes sense. If you can hear me, can you?
Yes, we can. Also, I suppose I should mention the sort of future proofing, you know, the more data we have about how the different macadamia clones cope with changing climate, you know, the better the farmers will be able to cope as the climate changes. Sorry, that was a bit circular, but you probably know what I mean.
Though I suppose if it's 4 or 5 years to get a yield, it's a big decision to change to a different clone.
Yes, yes, absolutely. But I think the trees only have a certain length of life, so it will come at a certain.
Oh yeah, sure.
I think you do have to think in quite long, you know, timescales on this.
Just muted Janet. Oops.
I'll wait for more questions. I'll jump in.
Right. Sorry, they've just come up. From Andy, thanks, John. Not so much a question, but a suggestion. Bat surveys are good for engaging students in urban ecology, as there will be pipistrelles around in most towns using gaps in roofs for roosting.
We have actually set up a audio moth for a little bit. It's not great, if I'm honest, around us. It's probably largely due to the sheer amount of building and construction that's happening in and around us at the moment. It's not that good for mammals. There's very little sign. There was a little bit of hedgehog poo that we found during one of our transects on one day. I should have also filled in that this is an entire year group that's undergone this reformed curriculum. That's 120 students, all abilities. And for me, the biggest benefit are those ones which are at the bottom end, the ones that typically don't enjoy science or didn't enjoy science, but really engaging them. Like the work I've shown you was from a lower set. I've got a bottom set this year, and they're running the same thing through, and it's still having those meaningful conversations, like the picture I showed you about them making like pinnates. How many 12-year-olds and 13-year-olds use that word when describing leaves? I think that's amazing, but they want to know what the right words are because they're invested in the quality of what they do. Catherine's just dropped a message in. So over the course of our kind of year, we were putting the ecology before Christmas. So the year 9s are kind of out, but using the school site 7 times during that first 3 months. If that helps you. But then the rest of the year, there's really not much in the way beyond that. See if there's is that a question for me, Jennifer, or?
No, it's my mantra. I want to get IBs all over the UK.
Yeah. I definitely think there is a very much a narrowing in the UK, but it's been like that for many years. My wife teaches IB, but their student numbers, most students still choose to do 3 A levels compared to the 5 kind of subjects and the extra little bits with the IB at her school. So she's maybe only got a group of like 5 or 6 students in her chemistry. And Adele, yeah, we've started putting that together, and we've hopefully talked to you in a year's time about a slightly different approach to that. So I'll just leave that one hanging, if it's okay, Adele.
John, can I just ask one which is related to some of these? As I understand it, your school has a very enlightened, if you like, mobile technology remit for the students, unlike some that I've come across recently. Would you like to say something about that, how it actually helps the students learning with relation to technology and mobile devices?
Yeah. We are actually trying to, every student brings in their own device to the school, so either that's a Chromebook or a laptop. We're kind of trying to dissuade them from using mobile phones. So things like iNaturalist, which would have been a bit of a potential in terms of the classification, but that's also a little bit of a shortcut in terms of them making the observations. So we've not gone down that line. We've tried to get them invested in them making the observations, them making the decisions, which helps them when it comes to their transects, because they are straight away saying, hey, look, that's a daisy. And they know, rather than relying on a mobile to tell them what that is. So they make a little herbarium. Usually it comes down to about 3 or 4 sheets of A4 that they take out for that session, that data collection. But as I showed you on the computers, the Desmos, where the students are able to put in little numbers, and straight away we can collect all of that and they can see it analysed in real time. And I think that's the benefit of each student having their own device, is that we can use class set data without having to compile it ourselves. So it improves the efficiency in terms of the classroom. Desmos is great for little things like drawing phylogenetic trees and little things like that as well.
A comment from Jennifer. A levels are outdated. The Royal Society is promoting 1B for post-16 education. Sorry, IB for post-16 education based on requirements for more practical and more project work. Would anybody in general like to comment on that? Because in a sense, that sustainability and field work is one of the things we're about.
I think from the A-level point of view, there's certain specifications are better than others and they'll offer a little bit more flexibility. Sometimes in some centres it might come across as a tick box to do the bare minimum and spend the time teaching the curriculum. But personally, I'm all about that kind of tethering the knowledge to the experience as well, and to offer that deeper meaning, whether that's on enzymes or whether that is succession. It's all that has to offer something to the students, and both in terms of knowledge and meaning.
Anybody, any other comments? We've still got a little bit of time. Tethering the knowledge to the experience, great logo phrase. Yes, thanks, Jennifer. That's anything else online? No, I can't.
Relocating. So maybe we use this time to move,
Yeah.
shall we? Okay. Well, thank you ever so much to all of the speakers for the session this morning. Everyone, round of applause again. Thank you online. Thank you very much. So the next part of the programme is a demonstration. Are we going to be staying online for